The table gives information about a population. We want to write down the Leslie matrix for that population. We can see there are 5 generations, and that means a 5 by 5 matrix. The birth rates always go in the top row. So 0, 1.3, 1.8, 0.9, and 0.2. Now for the survival rates. In the second row we put 0.6, and then the rest of the row is zeros. The 0.8 is for the second generation. We put that in the second column, and the rest of the row is 0. This 0.8 will be here, and the rest is 0. And the 0.4 would go here, with everything else being 0. If Tn denotes the total population after n years, we want to calculate the ratios T10 over T9 and T13 divided by T12. Since we're going to be doing calculations with this matrix, it's a good idea to program it in. So if we go to Interactive and Matrix Create and go for Fill, put in zeros everywhere since most of the matrix is zeros, and we want 5 rows and 5 columns, and that gives us this matrix. Now we'd like to edit this matrix, so let's put in the values that are non-zero. So 1.3, the next one is 1.8, and then the next one 0.9 and 0.2, and then this value here is 0.6. This one here is 0.8. This one here 0.8, and finally here 0.4. And what we're going to do is save that in a matrix that we're going to call L. At this stage, there's a couple of other matrices that are worth programming in. So we would like a column matrix with 5 rows that carries the initial population. So that's 194, 82, 55, 22, and 6. And I'm going to store that one in P for population, and then a row matrix that's just ones is handy for calculating the total population. So if we have 5 of those, and all of these need to be 1, could have done this with the matrix create, and I'll store that in A. Now, to get T9, what we need to do is take our matrix A and multiply that by L to the power 9, and multiply that by P and execute, and it gives us this one here, 3653, and so on. Now it's a good idea just to copy that. We'll paste it here, and then to get T10, just change the power to 10 and execute. And then once again, because we want also 12 and 13, changing the power to 12, and once again changing the power to 13. Now to calculate the ratios we're after, which was T10 divided by T9 to start with. So what I'm going to do, this was my T10 value. I could just drag that to here. I want to divide it by T9, which is this value here. So we'll just drag that down to the bottom and execute. 1.292 to 3 decimal places is required. So let's write that down. That's T10 divided by T9 was 1.292. And we also want T13 over T12. So we know that that's going to be this one here divided by the one above it, this one here, and it also gives us 1.292 to 3 decimal places. Using the results above, what do you notice about the population growth each year? Firstly, notice each generation is 1 year, so this is per generation. And then if we look at the values we got here, we can see it's a 29.2% growth. After 13 years, it's decided to cull 10% of all age groups at the beginning of each year. This is equivalent to using a new Leslie matrix. L dashed is 1 take away 0.10 L. Find the total population at the end of the 15th year. Note that this is just 0.9, so we're talking 0.9 L. But the first thing we need is the population after 13 years. So we can calculate that just by doing L to the power 13 multiplied by the population matrix. Note we don't need the A matrix here because we're after each generation, and that gives us this matrix here. Ignoring the decimals, or at least rounding, that gives us 5132 2383 1475 913 283. Although I'll use the amount on the calculator for the next calculation, this is enough to actually write down. Ignore this on the calculator, it's a calculation that I just got incorrect. So from the matrix that we just worked out, we now want the total population 2 years later, because we're talking about at the end of the 15th year, and this is the end of the 13th. So what we're going to do is we want A times, then we want 0.9 times our Leslie matrix, and then we want to times it by the population matrix. Actually, we want this squared because it's 2 years. And then this is the population matrix that we need to come down to here. And we calculate, and that's 13,777.5 and so on. So we'll call that 13778. So that's population 15. After 15 years, the population achieved in D is considered ideal. The culling rate of 10% will be modified to maintain this population. What new percentage culling rate is needed? We know if we do nothing, it's 1.292, 29.2% growth. So put that equal to 1 to maintain 100%. Then K is 1 over 1.292. So 1 divided by 1.292 gives us 0.774. This is the amount we want to survive, so therefore we're going to cull 1 take away 0.774. So we'll just do 1 take away this last answer, and that's 0.226. So it's going to be 22.6%.